Good morning, class. Today we are going to start with Rns theory of ionization. This theory suggests that when an electrolyte is dissolved in a water, it undergoes ionization to give charged particles called as ions. Positive charge, positive ion is called cation and negative ion is called anion. The total charge carried by cation is equal to charge carried by anion. Therefore, the overall solution is electrically neutral. The ion obtained by dissociation have a tendency to recombine to give back undissociated molecule. This leads to establishment of equilibrium between dissociated ions and undissociated molecules. The fraction of total number of molecules undergoing dissociation at equilibrium is called degree of ionization or degree of dissociation. It is denoted by alpha. So alpha is equal to number of molecules dissociated divided by total number of molecules. The value of alpha goes on increasing with a dilution and becomes maximum at infinite dilution. When electric field is applied to the solution, the ions moves under the influence of electricity. This leads to the conduction of electricity. Conductance of a solution is directly proportional to the number of ions and so degree of dissociation alpha. Now we are going to discuss Asphalt Dilution Law. This law states that for a weak electrolyte, the degree of dissociation alpha is directly proportional to the square root of dilution or inversely proportional to the square root of concentration. So just consider 1 mole of electrolyte AB. So this is the reaction. This is the electrolyte AB, which are in equilibrium with A plus B minus. So at initial concentration, AB remains as it is. So for 1 mole, value of AB is 1 and value of A plus and B minus is 0, 0. Now concentration at equilibrium. So according to Rns theory, there is an equilibrium between your dissociated ions and undissociated molecule. So let alpha number of molecules are dissociated. So because of that, at concentration of equilibrium, so at equilibrium concentration of AB is 1 minus alpha. So that's why concentration of A plus is alpha and B minus is also alpha. So for C number of moles, multiply all these with C, that is C into bracket 1 minus alpha, C alpha, C alpha. Now dissociation constant K, it is capital K. Don't confuse this K with specific conductance. Specific conductance in this chapter we denoted it with small k. Capital K is dissociation constant. So dissociation constant K is equal to concentration of A plus multiplied by concentration of B minus divided by concentration of AB. So we know concentration of A and concentration of B, that is C alpha divided by concentration of AB, that is C into bracket 1 minus alpha. After solving this, we comes with dissociation constant K is equal to C alpha square divided by 1 minus alpha. Now for very weak electrolyte, degree of dissociation is very small, that is alpha is very small than 1. So 1 minus alpha is approximately equal to 1. So K is equal to C alpha square divided by 1. So K is equal to C alpha square. So rearrange this equation for alpha square, which is written as alpha square is equal to K by C. So alpha is equal to under root of K by C. So degree of from this equation, K is dissociation constant. So we can see that alpha is inversely proportional to square root of concentration for weak electrolyte, and this is what Asphalt dilution law. So this is the mathematical expression for your Asphalt dilution law. Now we are going to see limitation of Rns theory. According to Rns theory, electrolytes undergo ionization only when dissolved in water. However, X-ray diffraction study have shown that many substances like NaCl, KCl exist as ions even in solid state with the formula Na plus Cl minus and K plus Cl minus. Rns theory suggests that electrolytes conduct electricity only when dissolved in water, but there are many substances which conduct electricity in a molten state. This shows that solvent is not necessary for ionization. Third drawback is that Rns theory suggests that the degree of dissociation increases with dilution. Hence, the conductance increases with dilution. However, strong electrolyte, for example NaCl, KCl, undergo complete dissociation at all dilution, and so their conductance should not change with dilution. However, it has been observed that conductance of strong electrolyte increases with dilution. This is the most serious limitation of Rns theory, because according to Rns theory, as the dilution increases, conductance should increases, but for strong electrolyte dissolve completely at all dilution, and because of that their conductance should not change with a dilution. Next is Asphalt dilution law based on Rns theory cannot be applied to strong electrolytes. Next drawback is the value of degree of dissociation of strong electrolytes obtained from equivalence conductance value was found to be different from those obtained by colligative property. So degree of dissociation value for strong electrolytes, when it is studied with the help of colligative property for same electrolyte, for example if it is NaCl and if we study it with colligative property, it's come, let's consider 550. So equivalence conductance study show it may be 480. So there is a big difference for same electrolyte. These are some drawbacks of your Rns theory. In our next class, we are going to discuss de Broglie theory of strong electrolyte. Thank you very much.